Good afternoon, my dear students. Today's class, let us discuss about the continuation part of structure of an atom. In the first part, already we have discussed about some concepts of structure of an atom. Today's class, let us discuss about Planck's quantum theory. So what do you mean by Planck's quantum theory? So it says that an atom or molecule can absorb or emits the energy in terms of discrete quantities, discrete quantities is called quanta. So what do you mean by quanta in terms of Planck's quantum theory? It says that an atom or molecule can absorb or emits the energy. The energy can be absorbed or releases in terms of discrete quantities is called quanta anta karitivi. So this is the question which may ask for 1 marks for the point of examination. What do you mean by quanta? So quantum of energy. So packets of energy antanu karitivi. So in terms of packets of energy or discrete quantities is called quanta anta karitivi. So always this quantum of energy is always directly proportional to quantum of energy is associated with directly proportional to frequency. So now we can write that is the quantum of energy E is directly proportional to mu. So now we can write E is equal to the proportionality constant is h mu. So the quantum of energy, the energy of each atom or molecule can be emitted energy or absorbed energy can be calculated with the help of this relation. E is equal to h mu. Calculate the energy of an atom with its frequency ಅಂತ ಕೊಡ್ತಾರೆ. ಕೊಟ್ಟಾಗ ಏನು ಮಾಡಬೇಕು, ನೀವು ಎನರ್ಜಿನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದಾಗಿದೆ. ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ದ ಪಾಯಿಂಟ್ ಆಫ್ ಎಕ್ಸಾಮಿನೇಷನ್ ಫಾರ್ 2 ಮಾರ್ಕ್ಸ್. ಈ ರಿಲೇಷನ್ ಮೇಲೆ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳನ್ನು ಕೇಳಬಹುದು. E is equal to h mu where h is equal to what here? Where h is Planck's constant. What is the value of Planck's constant ಕೇಳ್ತಾರೆ 1 marks ಗೆ. What is the value of Planck's constant? That is Planck's constant value is 6.026 into 10 to the power of minus 34 joules second. So this is the value of Planck's constant. So what is the Planck's constant value anta kelidre? The Planck's constant value is, so this is nothing but what value? Planck's constant value. Planck's constant value is 6.026 into 10 to the power of minus 34 joules second. This is nothing but Planck's constant value. So this may also ask for 1 marks. So ಇದನ್ನ 1 marks ಕೇಳಬಹುದು. And this relation ಮೇಲೆ 2 marks problem ಕೇಳಬಹುದು. ಅಥವಾ quanta ಅಂದ್ರೆ ಏನು? What do you mean by quantum of energy? Or quanta means what? Packets of energy ಅಂದ್ರೆ ಏನು? So that may ask for 1 marks. An atom or molecule can absorb or emits the energy in terms of discrete quantities of energy is called quanta ಅಂತ ಕರಿತೀವಿ. Okay, next let us go for photoelectric effect. Stop me. Now let us discuss about photoelectric effect. First of all, let us know about what do you mean by photo. Photo means light, electric means current. So photo, in presence of light, the electric charges are going to be discharges. So that is called as, that effect is called as photoelectric effects. So what happens here? So when and certain metals which when exposed to the sunlight or any suitable frequency of light, those metals can eject the electrons from its surfaces. Then such type of effects is called as photoelectric effect. In the presence of light, we can eject the electron from the surface of certain metals. That is called as photoelectric effect anta karitivi. So let us consider the definition. Photoelectric effect is defined as the phenomenon of ejection of electrons from the certain metal surfaces having metal surfaces to light, having certain minimum frequency is called photoelectric effect. So how do you define the term photoelectric effect? Photoelectric effect can be defined as the phenomenon of ejection of electrons from the certain metal surfaces. When these metal surfaces are exposed to light having certain minimum frequency, such light has to be contain certain minimum frequency ಇರಬೇಕು ಅಂತ ಮಿನಿಮಮ್ ಸರ್ಟನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರ್ತಕ್ಕಂಥ ಲೈಟ್ಸ್ಗಳಿಗೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತಲೂ ಕರಿತೀವಿ. ಸೊ ಲೈಟ್ ಹ್ಯಾವಿಂಗ್ ಮಿನಿಮಮ್ ಸರ್ಟನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಈಸ್ ಕಾಲ್ಡ್ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಎಫೆಕ್ಟ್ ಅಂತ ಹೇಳ್ಬೋದು. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಸೊ ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ ಎ ಚೇಂಬರ್ ಆಫ್ ಆ್ಯಂಡ್ ಮೆಟಲ್, so one of the surface is considered as cathode. So here is placed as metal, one is electrode cathode, another one is anode. So when we applied a certain frequency of light on the surface of a metal, some electrons are going to be ejected from the metal surface. So when you are going to be supposed to expose this metal can be either it may be cesium or potassium or rubidium. The metal may be like this. Such type of metals which when exposes to light, so this is a light, this light is having certain minimum frequency. The minimum frequency of light which when falls on the metal surfaces, that metal which is tendency to loses its electrons from its metal surfaces, then those electrons are ejected towards the anode. So this anode will abstract the electrons, so it can carry out through this circuit also. So this is about this is positive, this is negative. This is the process or phenomenon is called as photoelectric effect. So why we must choose cesium, potassium and rubidium for the ejection of electrons? So these elements can easily eject the electrons from its outermost orbital. Why? Because these elements are having low ionization enthalpy. So because of low ionization enthalpy, these metals can be used to eject the electrons from the metal surfaces. If you consider the sodium and lithium, so these elements are can't able to release the electrons from their metal surfaces. Why? Because which requires higher the ionization enthalpy. What do you mean by ionization enthalpy? The amount of energy required to eject the electron from the outermost orbital is very high. So amount of energy required to eject the electron. So ಇವುಗಳಿಗೆ amount of energy ಏನು ಬೇಕು? ಜಾಸ್ತಿ ಬೇಕು. ಸೊ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಇದ್ದರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಎಜೆಕ್ಟ್ ಆಗ್ತವೆ. ಬಟ್ ಇವುಗಳಿಗೆ ಏನು ಬೇಕು, ಮಿನಿಮಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಲೈಟ್ ಇದ್ರೆ ಸಾಕು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಜೆಕ್ಟ್ ಆಗ್ತದೆ ಈ ಎಲಿಮೆಂಟ್ಸ್ ಇಂದ. ಅದಕ್ಕಾಗಿ ಇನ್ ದಿಸ್ photoelectric effect we are choosing the metals like cesium, potassium and rubidium. So these elements are suitable for the photoelectric effect process. That's why this is the process is called as photoelectric effect. So what do you mean by photoelectric effect? It may ask for 2 marks. For the point of examination 2 marks ಕೇಳಬಹುದು. Photoelectric effect ಅಂದ್ರೆ ಏನು? So name the elements chosen for the metal surfaces in the photoelectric effect ಅಂತ ಕೇಳಿದ್ರೆ the elements chosen for the surface of metal is cesium, potassium, rubidium. So why these cesium and potassium are chosen for the photoelectric effect means these elements are having low ionization enthalpy. That's why these are suitable for the photoelectric effect. So the phenomenon of ejection means removal of electron from the surface of its metal, that is ejection anta ಕರಿತೀವಿ. From what? From metal surface. This is metal, its surface ಇಂದ eject ಆಗ್ತವೆ electrons. ಯಾವಾಗ? When we supposed to apply the suitable frequency of light on these surfaces. So are exposed to light, that light must having minimum frequency. ಆ ಲೈಟ್ ಏನಿರಬೇಕು, ಮಿನಿಮಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರಬೇಕು. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಎಫೆಕ್ಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಇಲ್ಲಿ ಇನ್ನೊಂದು ಡೆಫಿನೇಷನ್ ಕೂಡ ಕೇಳ್ತಾರೆ. ಸೊ ಇನ್ನೊಂದು ಡೆಫಿನೇಷನ್ ಏನಂದರೆ ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಸೊ ಇನ್ನೊಂದು ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂದರೆ ಏನಂತ, ವಾಟ್ ಡು ಯು ಮೀನ್ ಬೈ ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ? ಡಿಫೈನ್ ದ ಟರ್ಮ್ ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಒಂದು ಮಾರ್ಕ್ಸ್ ಕೇಳ್ತಾರೆ. ವಾಟ್ ಡು ಯು ಮೀನ್ ಬೈ ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ? The minimum amount of energy required to eject the electrons from the metal surface is called, that frequency is called threshold frequency. The minimum amount of frequency which is required to eject the electron from the metal surfaces is called as threshold frequency ಅಂತ ಹೇಳ್ತೀವಿ. Stop now. So I have written the definition for the threshold frequency. As I told that threshold frequency is defined as the minimum frequency of radiation requires to show the photoelectric effect is called threshold frequency. Means that here to eject the electron, so ಇಲ್ಲಿ electron eject ಆಗಬೇಕಂದ್ರೆ ಏನು ಬೇಕು ನಮಗೆ? minimum frequency of radiation ಬೇಕು. The minimum frequency of radiation requires to show the photoelectric effect. Photoelectric effect ಅಂದ್ರೆ ಏನು? When the electrons are ejected, when we supposed to apply the certain frequency of light on the metal surfaces, at the time the electrons are going to be ejected, that process or phenomenon is called as photoelectric effect. That's why here the minimum frequency of radiation required to show the photoelectric effect is called threshold frequency. This is important for the point of examination for 1 marks. Now let us discuss about dual nature of electromagnetic radiation. So some lights which behaves like dual in nature. Some lights can behaves like a wave like particles or sometimes stream of particles. Light behaves as a wave or as a stream of particles. So what do you mean by wave? So wave is in the sense, so waves, so this is an waves. So sometimes light can appearance in the form of waves or as a stream of particles, or as like a stream of particles, the number of particles which way comes. So in that form also we can observe the light. So that's why here dual nature of electromagnetic radiations, it says that some electromagnetic radiations or lights behaves as a wave like nature or as a stream of particle nature. Here 2 types of nature can be seen, wave like nature and another one is particle like nature. So when radiations interacts with matter, so whenever the radiations which are interact with the matter means anything which can occupies by space and mass is called matter, in such a way that it displays particle like properties. So ಯಾವಾಗೆ ಇಲ್ಲಿ radiations, if it is interact with matter, so at that time we can say that that type of properties are always called as particle like properties ಅಂತ ಹೇಳ್ತೀವಿ. So while similarly when it propagates, whenever the light which is propagates, this is the propagation line. On that propagation line the number of waves are propagating, so that is propagation. When it propagates, it displays wave like particle properties. It is a wave like properties. Wave is nothing but this is a wave. This is a propagation line. On this propagation line, the number of waves are propagating. So this kind of nature or properties is called as wave like nature ಅಂತ ಕರಿತೀವಿ. ಯಾವಾಗೆ ರೇಡಿಯೇಷನ್ಸು ಸ್ಟ್ರೀಮ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಈ ಥರ ಬಂದ್ಬಿಟ್ಟು ವಿಚ್ ವೆನ್ ಇಂಟ್ರಾಕ್ಟ್ ವಿತ್ ದ ಮ್ಯಾಟರ್ ದೆನ್ ಸಚ್ ಟೈಪ್ ಆಫ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆರ್ ಆಲ್ವೇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಸೊ ಪಾರ್ಟಿಕಲ್ ಲೈಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಇದಕ್ಕೆ ಪ್ರೊಪಗೇಷನ್ ಬಂತು ಅಂತಂದರೆ ಅವುಗಳಿಗೆ ವೇವ್ ಲೈಕ್ ನೇಚರ್ ಇದೆ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದಿ ಡಿಯಲ್ ನೇಚರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರೇಡಿಯೇಷನ್ಸ್. ಸೊ ಒನ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಡೆಫಿನೇಷನ್ is emission spectrum and absorption spectrum. So what do you mean by emission spectrum? The spectrum of radiation emitted by a substance that has absorbed energy is called emission spectrum. So what do you mean by emission spectrum? The spectrum of radiation emitted by a substance. So illinda emission agute, it is emitted by a substance that has absorbed energy. By absorption of energy, that substances can emit the radiations, that spectrum is called as emission spectrum anta heltivi. So similarly, one more definition, absorption spectrum. So here the spectrum is obtained by the spectrum is obtained by the spectrum is obtained by the absorption of energy. Absorption of energy. Absorption of energy is called absorption spectrum. Is called absorption spectrum anta ಹೇಳ್ತೀವಿ. So what do you mean by absorption spectrum or what do you mean by emission spectrum? ಯಾವುದಾದ್ರೂ ಒಂದು ಮಾರ್ಕ್ಸ್ ಕೇಳಬಹುದು. So what do you mean by emission spectrum? What do you mean by absorption spectrum? Here absorption spectrum means the spectrum is obtained by the absorption of energy. The any substance which can absorb some quantities of energy and such substances can gives the spectrum that is called absorption spectrum. Always these are obtained in terms of dark lines. So dark lines of the spectrums are always called as absorption spectrum anta heltivi. Okay, stop now. Dear students, now let us discuss about the Bohr's postulates of an atom. So it is very important for your examination. It will carry 4 marks. So that's why I have written all the points here. Now I will explain you the points of this Bohr's postulates of an atom. So according to Bohr's, what do you mean by atom? So according to Bohr's, what do you mean by atom? Those are called as postulates. So according to Bohr's, ಏನಲ್ಲ atom ಅಂದರೆ ಏನೆಲ್ಲ ಒಳಗೊಂಡಿರ್ತದೆ, atom ಅಂದರೆ ಹೇಗಿರುತ್ತೆ, what is the structure of an atom ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಬೋರ್ಸ್ ರವರು ತಿಳಿಸ್ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ಆ ಒಂದು ಬೋರ್ಸ್ ರವರ ಥಿಯರಿ ನಿಯಮವನ್ನು ನಾನೀಗ ನಿಮಗೆ ಒಂದೊಂದಾಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. The first point, the electrons are revolving around the nucleus, so in a circular path called orbit. So here orbit or shell. So what do you mean by orbit or shell? Here read the point, electrons are revolving around the nucleus. So here there is a presence of nucleus, so around that nucleus there is a presence of number of orbits. These are the number of orbits are surrounding by the nucleus. So in these orbits, this is a circular path. What do you mean by orbit? Circular path is called an orbit or shell anta karitivi. So these can be represented in terms of shells, K shell, L shell, M shell or N shell, the name of the shells. Or we can also represent these shells in terms of energy level, that is n is equal to 1, this is n is equal to 2, this is n is equal to 3, this is n is equal to 4. This is 1, 2, 3, 4 are the energy levels. K, L, M, N are the shells, name of the shells. So here those are represented by, those orbits or shells are represented by K, L, M, N, etc. or energy levels, n is equal to 1, 2, 3, 4. So here I have represented, this is a nucleus, this is what? Nucleus. That nucleus is surrounded by the number of orbits. Those orbits having some number of electrons. Those electrons are revolving around the nucleus. Stop on. Okay, this is about the nucleus. Nucleus surrounded by the number of orbits. Those orbits carrying an electrons. These electrons are revolving in a orbit. Orbital electrons revolve ಆಗ್ತಾ ಇರ್ತದೆ ಅಂತ ಹೇಳ್ತಾರೆ ಮೊದಲನೇ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ. Okay, now let us go for second point. As long as electrons revolve around the nucleus, neither emit or nor absorb the energy. So while revolving the electrons, ಈ ಏನು electrons ಇದಾವಲ್ಲ, while revolving these electrons which neither emit, ಎನರ್ಜಿನ ಎಮಿಟ್ ಮಾಡೋದಿಲ್ಲ ಮತ್ತು ಎನರ್ಜಿನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ. ಸೊ ಸಚ್ ಕೈಂಡ್ಸ್ ಆಫ್ ಪ್ರಾಪರ್ಟೀಸ್ ಈಸ್ ನೋನ್ ಆಸ್, ದಟ್ ಸ್ಟೇಟ್ ಈಸ್ ನೋನ್ ಆಸ್ ಆರ್ ಕಾಲ್ಡ್ ಸ್ಟೇಷನರಿ ಸ್ಟೇಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ವಾಟ್ ಡು ಯು ಮೀನ್ ಬೈ ಸ್ಟೇಷನರಿ ಸ್ಟೇಟ್ ಆರ್ ಎನರ್ಜಿ ಲೆವೆಲ್? ಸೊ ಸ್ಟೇಷನರಿ ಸ್ಟೇಟ್, ಸ್ಟೇಷನರಿ ಅಂದರೆ ವಿತೌಟ್ ಅಬ್ಸಾರ್ಬಿಂಗ್ ಆರ್ ಎಮಿಟಿಂಗ್ ದ ಎನರ್ಜಿ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ರಿವಾಲ್ವಿಂಗ್ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಸ್ಟೇಷನರಿ ಸ್ಟೇಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಆಸ್ ಲಾಂಗ್ ಆಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿವಾಲ್ವ್ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್, ನೈದರ್ ಎಮಿಟ್ ಅಂದರೆ ಎನರ್ಜಿನ ರಿಲೀಸ್ ಮಾಡ್ತಕ್ಕಂಥದ್ದು, ನಾರ್ ಅಬ್ಸಾರ್ಬ್, ಎನರ್ಜಿನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ, ನಾರ್ ಅಬ್ಸಾರ್ಬ್ ದ ಎನರ್ಜಿ. ದೀಸ್ ಸ್ಟೇಟ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಸ್ಟೇಷನರಿ ಸ್ಟೇಟ್ಸ್ ಆರ್ ಎನರ್ಜಿ ಲೆವೆಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ದೀಸ್ ಆರ್ ದಿ ಎನರ್ಜಿ ಲೆವೆಲ್ಸ್ ಆರ್ ಸ್ಟೇಷನರಿ ಸ್ಟೇಟ್ಸ್ ಅಂತಲೂ ಕರಿತೀವಿ. So next let us go for third point. The angular momentum of an electron are equal to integral multiple of h by 2 pi, or mvr is equal to n h divided by 2 pi. So the integral part, the angular momentum of an electron, the angular momentum ಏನಿರ್ತದಲ್ಲ, that is always equal to integral multiple ಆಗಿರುತ್ತೆ, that is h by 2 pi. So that can be written as the mass of an electron, the velocity of an electron, the radius of an electron is always equal to n h divided by 2 pi. So n is the state of the shell or state of the orbit. N is equal to what? N is equal to 1, 2, 3, 4. Okay, here the mass of an electron, velocity of an electron, radius. So always ಇಲ್ಲಿ the electron revolve ಆಗ್ತಿದೆ ಅಂತಂದ್ರೆ that electron which consisting of mass and velocity and its radius also, that is always equal to integral multiple, that is h by 2 pi ಏನಿದೆ. here n ಯಾವ ಎಲೆಕ್ಟ್ರಾನ್ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿರುತ್ತದೋ ಆ n ವ್ಯಾಲ್ಯೂನ ತಗೋಬೇಕಾಗ್ತದೆ. ಸೆಕೆಂಡ್ ಸೆಲ್ ಆರ್ ಥರ್ಡ್ ಸೆಲ್ ಆರ್ ಫೋರ್ತ್ ಸೆಲ್ ಆ ವ್ಯಾಲ್ಯೂನ ತಗೋಬಹುದು. that is mvr is equal to n h divided by 2 pi. As you know that the h is Planck's constant, that is 6.623 into 10 to the power of minus 34 joule second. Okay, next let us go for next point, that is if electrons jumps from higher energy level to, see observe here, higher energy level to lower energy level. Nodi, so whenever the electrons are exciting from higher energy level to lower energy level, if it is n is equal to 1, if it is n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6, these are the energy levels. So whenever one electron which is exciting from higher energy level to lower energy level, so this is an electron which is present at higher energy level, whenever the electrons are exciting from higher energy level to lower energy level, at that time the energy is emitted. Energy is emitted, energy emit ಆಗುತ್ತೆ, ರಿಲೀಸ್ ಆಗುತ್ತೆ while exciting the electron from higher energy level. This is higher energy level. higher energy level ಇಂದ ಏನಾಗುತ್ತೆ, lower energy level ಗೆ ಜಂಪ್ ಆಗ್ತಾ ಇದೆ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಹೈಯರ್ ಎನರ್ಜಿ ಲೆವೆಲ್ ಇಂದ ಲೋವರ್ ಎನರ್ಜಿ ಲೆವೆಲ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಜಂಪ್ ಆಗಬೇಕಾದ್ರೆ ಇಲ್ಲೇನಾಗುತ್ತೆ, ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗುತ್ತೆ. the energy will emitted, energy emit ಆಗುತ್ತೆ. ಸೊ ಅದೇ ರೀತಿ if electrons jumps from lower energy level to higher energy level, ನೋಡಿ lower energy level ಅಂದ್ರೆ ಯಾವುದು, ಇದು n is equal to 1 is the lower energy level, n is equal to 6 is the higher energy level, n is equal to 1 lower energy level. lower energy level ಇಂದ electron higher energy level ಗೆ jump ಆಗಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ, energy has to be absorbed. So by absorbing some quantity of energy, this electron will get kinetic energy and this electron will move to higher energy level. So that's why to excite the electron from higher energy level to lower energy level, no need to give the external additional energy or any quantity of energy. So that will release us electron from higher energy level to lower energy level without gaining the energy. By loss of its energy, kinetic energy loss ಆಗುತ್ತೆ ಇಲ್ಲಿ. kinetic energy is equal to minus, kinetic energy is minus, here kinetic energy requires, kinetic energy is equal to plus. So amount of energy required to eject the electron from lower energy level to higher energy level, That's why here lower energy level to higher energy level energy is absorbed. ಎನರ್ಜಿ ಏನಾಗುತ್ತಂತೆ, ಎನರ್ಜಿ ಅಬ್ಸಾರ್ಬ್ ಆಗುತ್ತೆ. ಎನರ್ಜಿನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡಿಕೊಂಡು ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗುತ್ತೆ ಹೈಯರ್ ಎನರ್ಜಿ ಲೆವೆಲ್ಗೆ ಎಸ್ಕೇಪ್ ಆಗ್ತದೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದಿ ಫೋರ್ತ್ ಪಾಸ್ಟುಲೇಟ್ಸ್. ನೆಕ್ಸ್ಟ್ ಲಾಸ್ಟ್ ಪಾಸ್ಟುಲೇಟ್ ಈಸ್ ಎನರ್ಜಿ ರಿಲೀಸ್ಡ್ ಆರ್ ಅಬ್ಸಾರ್ಬ್ಡ್ by an electron is equal to the difference in energies of the two orbits and is equal to the energies of a quantum of radiation. So the difference, the energy released or absorbed, ಎಷ್ಟು ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಯಿತು, ಎಷ್ಟು ಎನರ್ಜಿ ಅಬ್ಸಾರ್ಬ್ ಆಯಿತು. ಯಾವಾಗ ರಿಲೀಸ್ ಆಗುತ್ತೆ ಎನರ್ಜಿ? ವೆನ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಚ್ ಇಸ್ ಎಕ್ಸೈಟೆಡ್ ಫ್ರಮ್ ಹೈಯರ್ ಎನರ್ಜಿ ಲೆವೆಲ್ ಟು ಲೋವರ್ ಎನರ್ಜಿ ಲೆವೆಲ್. ಸೊ ವೆನ್ ದ ಎನರ್ಜಿ ಈಸ್ ಅಬ್ಸಾರ್ಬ್ಡ್, ವೆನ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಎಕ್ಸೈಟೆಡ್ ಫ್ರಮ್ ಲೋವರ್ ಎನರ್ಜಿ ಲೆವೆಲ್ ಟು ಹೈಯರ್ ಎನರ್ಜಿ ಲೆವೆಲ್, ದಟ್ ಎನರ್ಜಿ ಡಿಫರೆನ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಡೆಲ್ಟಾ ಇ ಈಸ್ ಈಕ್ವಲ್ ಟು E2 minus E1. So higher energy level minus lower energy level, that gives the change in energy or difference in energy between so absorbed energy and released energy. So absorbed ಆದಾಗ ಏನಾಗುತ್ತೆ, ಅದು ಎಲೆಕ್ಟ್ರಾನ್ ಎಕ್ಸೈಟೆಡ್ ಆಗಿರುತ್ತೆ. ಯಾವಾಗ ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗುತ್ತೆ ಅವಾಗ ಸೊ ಎನರ್ಜಿ ಎಮಿಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಟ್ ಎಮಿಟೆಡ್ ಎನರ್ಜಿ ಆರ್ ಅಬ್ಸಾರ್ಬ್ಡ್ ಎನರ್ಜಿ ಕ್ಯಾನ್ ಬಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಚೇಂಜ್ ಇನ್ ಎನರ್ಜಿ, ದಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು E2 minus E1. So with the help of these postulates we can conclude the atom according to Bohr's. Bohr's who state that atom is looks like this. Atom consisting of nucleus. Nucleus it is surrounded by number of orbits. Those number of orbits are revolving in a circular path. That circular path is called as an orbit or shell ಅಂತ ಹೇಳ್ತಾರೆ. Those can be named as K, L, M, N ಅಂತ ಹೇಳ್ತೀವಿ. And their energies are 1, 2, 3, 4 etc. And here as long as electrons are revolving around the nucleus, so the energy may be neither emitted nor absorbed. These states are nothing but stationary states ಅಂತ ಹೇಳ್ತೀವಿ or energy levels ಅಂತ ಹೇಳ್ತೀವಿ. The angular momentum of an electron is always equal to that of the integral multiple ಅಂತ ಹೇಳ್ತೀವಿ h divided by 2 pi, or that is mvr, mass of an electron, velocity of an electron or radius of an electron is always equal to nh divided by 2 pi. The electrons may jump from higher energy level to lower energy level, then the energy is emitted ಆಗ್ತದೆ ಅಂತ ಹೇಳ್ತೀವಿ. So when if the electrons are jumping from lower energy level to the higher energy level, at that time energy is absorbed. So ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಮೇಲೆ ಹೋಗ್ಬೇಕಂತಂದ್ರೆ ಏನು ಬೇಕು, ಇದಕ್ಕೆ ಸ್ವಲ್ಪ ನಾವು ಹೀಟ್ ಮಾಡಬೇಕು. ಹೀಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಇಟ್ ಗೆಟ್ ಸಮ್ ಎನರ್ಜಿ, ದಟ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಇಮಿಡಿಯೇಟ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಎಕ್ಸೈಟ್ ಆಗಲಿಕ್ಕೆ ಚಾನ್ಸಸ್ ಆಗ್ತದೆ. ಸೊ ಹಾಗಾಗಿ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿಗೆ ಏನಾಗುತ್ತೆ, ಅಟ್ ದ ಟೈಮ್ ಇಟ್ ಈಸ್ ಅಬ್ಸಾರ್ಬ್ಸ್ ದ ಎನರ್ಜಿ. ಅಡಿಷನಲ್ ಎನರ್ಜಿ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡು ಏನಾಗುತ್ತೆ, ಎಕ್ಸೈಟೆಡ್ ಎನರ್ಜಿ ಲೆವೆಲ್ಗೆ ಹೋಗುತ್ತೆ. ಸೊ ದ ರಿಲೀಸ್ಡ್ ಎನರ್ಜಿ ಆರ್ ಅಬ್ಸಾರ್ಬ್ಡ್ ಎನರ್ಜಿ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಆಲ್ವೇಸ್ ಈಕ್ವಲ್ ಟು ದ ಡಿಫರೆನ್ಸ್ ಇನ್ ಎನರ್ಜೀಸ್ ಆಫ್ ದಿ ಟೂ ಆರ್ಬಿಟ್ಸ್ ಅಂಡ್ ಇಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ದ ಎನರ್ಜೀಸ್ ಆಫ್ ಕ್ವಾಂಟಮ್ ರೇಡಿಯೇಷನ್, ದಟ್ ಈಸ್ ಡೆಲ್ಟಾ ಇ ಈಸ್ ಈಕ್ವಲ್ ಟು E2 minus E1. ಸೊ ದೀಸ್ ಆರ್ ಆಲ್ ಅಬೌಟ್ ದಿ postulates of an Bohr's postulates of an atom. Thank you.